So now we will discuss NaN and NaN in Pandas. So NaN and NaN both have their place, and Pandas is built to handle the two of them nearly interchangeably, converting between them where appropriate. PD dot 1 and P dot NaN 2. For types that don't have an available sentinel values, Pandas automatically type casts when NA values are present. For example, if we set a value in an integer array to np.nan, it will automatically be upcast to a floating point type to accommodate the NA. Now, let's start it. X is equals to pd dot series range to d type equals to int x. We got the result this. Now x 0 x is equals to none, and we will get NaN. So notice that in addition to casting the integer value to floating point, Pandas automatically convert the NaN to NaN value. Be aware that there is a proposal to add a native integer NA to Pandas in the future. As of this writing, it has not been included. While this type of magic may feel a bit hackish compared to the more unified approach to NA values in domain-specific languages like R, the Pandas Sentinel casting approach works quite well in practice, and in my experience only rarely causes issues. Keep in mind that in Pandas, string data is always stored with an object D type. Okay, so you can see the table here, which is Pandas handling of NAs by type. Floating object integer boolean. Conversion when storing NAs for floating is no change, and NA sentinel values np.nan, and you can see the rest of it. So now let's discuss operating on null values.